Over 300 million people worldwide are currently practicing some form of intermittent fasting. But here is the shocking part: the majority of them are doing it based on advice that is either incomplete, outdated, or flat out wrong. And what the actual peer-reviewed science says about fasting might completely change how you think about food, time, and your own biology. In the next 10 minutes, you are going to discover what decades of clinical research actually reveal about intermittent fasting, why some of the most popular claims about it are only partially true, and what the science says about who it genuinely helps versus who it might be hurting. There is one finding from a major 2024 study that shook the nutrition world, and we will get to it. Stick around, because the full picture is far more nuanced than any Instagram post has ever told you. Fasting is not a modern invention. Human beings have been fasting throughout their entire evolutionary history, not necessarily by choice, but because food was simply not always available. Our ancestors did not eat 3 structured meals a day with snacks in between. They hunted, gathered, succeeded sometimes, and went without food other times. The body evolved to handle this. It developed systems for storing energy, mobilizing it during scarcity, and protecting critical organs when calories were unavailable. That biological machinery is still inside every single one of us right now. Religious and cultural fasting practices stretch back thousands of years. Ancient Greek physicians used fasting as a medical tool. Hippocrates himself advocated for it. Islamic Ramadan, Jewish Yom Kippur, Buddhist fasting days, across every major world culture, deliberate fasting appears as both a spiritual and physical practice. The modern scientific interest in intermittent fasting as a structured health intervention, however, really accelerated in the late 1990s and early 2000s, when researchers began studying caloric restriction and longevity in animal models, then started asking whether timing of eating mattered as much as total calories consumed. So what exactly is intermittent fasting from a scientific standpoint? At its core, it is not a diet in the traditional sense. It does not specify what you eat. It specifies when you eat. The most studied protocols include the 16:8 method, where you eat within an 8-hour window and fast for 16 hours. There is also the 5:2 approach, eating normally 5 days a week and restricting calories dramatically on 2 non-consecutive days. And there is alternate day fasting, which alternates between normal eating days and very low-calorie days. Each of these creates a different metabolic environment in the body, and the science treats them quite differently. Here's what the research consistently confirms. When you fast for extended periods, typically beyond 12 to 14 hours, your body begins depleting its glycogen stores in the liver and muscles. Once those are low enough, it starts transitioning to burning fat for fuel. Insulin levels drop significantly, which is critical because elevated insulin is one of the primary barriers to fat oxidation. Growth hormone levels increase, sometimes dramatically, which supports muscle preservation. And a cellular cleaning process called autophagy begins to ramp up. The body starts recycling damaged cellular components. These are measurable, reproducible biological events. They are not hypothetical. But here's what nobody talks about enough. The magnitude and timing of these effects varies enormously between individuals. A 2022 study published in the journal Cell Metabolism found that metabolic responses to identical fasting protocols differed by as much as 40% between participants depending on their baseline insulin sensitivity, microbiome composition, sleep quality, and prior dietary patterns. The idea that intermittent fasting produces uniform results across all people is simply not supported by the current evidence base. What about weight loss? This is where most people start, and the research here is genuinely interesting. Multiple randomized controlled trials confirm that intermittent fasting does produce meaningful weight loss. A 2020 meta-analysis in the journal Obesity Reviews, which pooled data from 27 separate trials, found that intermittent fasting produced average weight losses of around 0.8 to 1.3% of body weight per week during active protocols. That is clinically significant. However, and this is the critical part, when researchers directly compared intermittent fasting to continuous calorie restriction, where total calories were matched, the weight loss outcomes were nearly identical. The fasting itself was not magic. The calorie deficit was doing most of the work. So why bother with fasting at all if it comes down to calories in the end? Because for many people, restricting the eating window makes it significantly easier to maintain a calorie deficit without constant tracking and willpower expenditure. Hunger hormones, particularly ghrelin, tend to adapt to feeding patterns over time. Studies show that people who consistently eat within a compressed window often report reduced appetite during fasting hours after 2 to 3 weeks. The practical adherence advantage is real, even if the biochemistry is more complicated than the popular narrative suggests. Now here is where things get genuinely fascinating. The benefits of intermittent fasting that are showing the most scientific promise have nothing to do with weight loss at all. They are about metabolic health, brain function, and cellular maintenance. Research from the Salk Institute and published work from neuroscientist Sachin Panda has demonstrated that time-restricted eating, even without any calorie reduction, improved blood glucose regulation, reduced blood pressure, and decreased inflammatory markers in metabolic syndrome patients. The timing of food intake relative to your circadian rhythm appears to be an independent variable affecting health outcomes, separate from calories entirely. Cognitive function is another area drawing serious research attention. Animal studies have consistently shown that intermittent fasting increases production of brain-derived neurotrophic factor, or BDNF, a protein that supports neuron growth and protects against cognitive decline. Human trials are still catching up, but early findings are encouraging. A 2021 pilot study from the University of Toronto found measurable improvements in working memory and processing speed in adults who followed a 16:8 protocol for 8 weeks compared to a control group. But here is the counterintuitive finding that made headlines in 2024. A large observational study presented at the American Heart Association scientific sessions found that adults following an eating window of fewer than 8 hours per day had a 91% higher risk of cardiovascular death compared to those eating across 12 to 16 hours. This sent shockwaves through the fasting community. But the critical context is this: it was an observational study, not a controlled trial. It could not establish causation. Participants were not randomly assigned. People who eat in very compressed windows may already have other health risk factors skewing the data. The scientific community responded with appropriate caution. The finding warrants further research, not panic, but it is a serious signal that aggressive fasting protocols are not inherently safe for everyone. This brings us to the population question. Who does intermittent fasting most reliably benefit according to current evidence? Overweight adults with insulin resistance and metabolic syndrome show some of the strongest and most consistent positive outcomes. People who struggle with portion control but not disordered eating may find the structure highly practical. Athletes doing strength training have shown they can preserve lean mass during fat loss phases when protein intake remains high within the eating window. Who should approach it with significant caution or avoid it? Pregnant or breastfeeding women. Individuals with a history of disordered eating. People with type 1 diabetes or those on insulin-adjusting medications without medical supervision. Adolescents and children whose growth demands consistent nutrient availability. And anyone with a history of hypoglycemia. The science here is not ambiguous. These are populations where the risk-benefit calculation looks very different. The honest conclusion from the totality of current evidence is this: intermittent fasting is a legitimate, evidence-supported tool with real and meaningful benefits for specific populations and specific health goals. It is not a universal cure, and it is not the revolutionary paradigm shift that some advocates claim. The metabolic benefits related to circadian alignment and cellular repair are genuinely promising and likely independent of weight loss. The weight loss benefits are real but largely explained by calorie reduction rather than unique fasting-specific mechanisms. And the safety profile, while generally good for healthy adults, is not universally positive, particularly with very aggressive protocols. The science also makes clear that consistency matters more than perfection. A moderate, sustainable fasting window practiced consistently over months produces better long-term outcomes than aggressive protocols practiced for a few weeks and abandoned. Your body responds to patterns, not single events. Intermittent fasting is not magic, and it is not a myth. It sits in the honest, complicated middle ground where most real science lives, genuinely useful, context-dependent, and still actively being understood. The most important thing you can do is evaluate it against your own health baseline, ideally with a healthcare provider who knows your individual picture. Disclaimer: this video is for general wellness purposes only. Always consult your healthcare provider before starting any fitness or nutrition program. Before you go, if you learned something new today, hit that like button right now. It genuinely helps this channel grow. Subscribe to HealthCore Daily for a new video every single day. We will see you in the next one.